Math Hour. I am going to go over chapter, I believe it's chapter 5 from the Math 1324, which is simple and compound interest annuities. So these are the topics that I'm going to cover right now. Simple interest, I believe it's section 5.1. Compound interest, section 5.2. Future value annuities, 5.3. And present value annuities, 5.4. Okay, first of all, let's start with simple interest. Okay, for simple interest, there's two different types of formulas. For example, I believe the book says I for simple interest, but I put INT. Simple interest equals to the present value. This is a fee paid to use someone else's money. That's the interest. The PV stands for present value or the principal. The R is the interest rate. It's always in a percent symbol. And T is time in years. Okay, now here's the other formula that we're going to derive from the first formula here. So for example, the interest is PV, the present value, times R times T. So here, what do they have in common? These two terms, they have in common the PV, right, the present value. So I'm going to factor it out. So what's left? 1 plus R times T. So this is the other formula that you can use for simple interest. So again, for simple interest, there's two formulas. Let's call this formula number 1 and this formula number 2. Formula number 2 is when you're trying to find the future value. Okay, and formula number 1 over here is when you're trying to find the interest. And again, AV stands for the sum of the principal and the interest earned. The PV stands for the, again, present value or principal, and the R stands for interest rate, and T is time in years. The FV, it can also stand for future value, the sum of the principal and interest earned, right, in the future. So let's start with an example. Okay, before we start, you need to know this, okay? If months are given for time, then T is going to be given months over 12. This is very important. You got to know that. And here's where a lot of students make a mistake, because if they give you, say, 5 months, they put 5 for T, which is wrong, because 5 means that it's 5 years. So if it's 5 months, it's going to be 5 divided by 12. Okay? And the interest rate must be in decimal. So you're going to move the decimal 2 places to the left, and you drop the symbol. You see, for example, if it's 5%, you move it 2 to the left, you drop the symbol. So like 5% is the same thing as 0.05. These two you need to know. So let's start with an example. Okay, let's see here. Example 1. Martha borrowed $12,000 from her uncle to buy a used car. Her uncle charged simple interest at 3.5% for 5 years. Find the total amount that Martha paid to her uncle and how much interest did Martha pay. So here, which formula should we use? The simple interest, right? The simple interest equals to the present value, interest rate times time, or the one with the future value equals to present value, parentheses 1 plus interest rate times time. Doesn't matter. For this particular problem, it doesn't matter. Okay, no. I'm going to do this very same example using both formulas so you guys can see the difference. Okay. So for example, if we use the formula, the simple interest equals to the present value, interest rate times time, then you also have to use this other formula with it. Because here, right, we're find the total amount that Martha paid, right? So we're looking for the future value, and also how much interest did Martha pay. So if we use this formula, right, we're going to find the interest first that Martha paid. Then we're going to add it to the present value, how much money she borrowed, and then that'll give me the future value. Okay, let me show you what I'm trying to say here. So first of all, right, so if we use this formula. Okay, we're gonna, let's see, what does it give us? Martha borrowed $12,000, right? So that's gonna be my present value. Her uncle charged simple interest of 3.5%, so 3.5% will be my interest rate. And remember, we have to convert it to a decimal, so we move it to the left two places, and we drop the symbol. So it's going to be 0.035. And the time is 5, right? It's 5 years, so the time is okay. So let's plug everything into the formula. Right, so my present value was 12,000, my interest rate was 0.035, and my time was 5 years. So all you do is put it in the calculator, and this is what you get, 2,100. So then, right, so this answer here was how much interest did Martha pay, which is 2,100 or 2,100. Now to find the total that Martha paid her uncle, then we have to add, right, the present value, how much money she borrowed, plus the interest that she has to pay along with the present value. So the present value was 12,000, and the interest that she paid was 2,100. If we add it up, it's going to give us $14,100. So that's how much Martha paid her uncle in 5 years. And how much interest did she pay? She paid $2,100 of interest. Okay, now let me use a very same example, but now instead of using the formula number 1, let's use the other formula, which is the future value. Okay. So then, right, I like to set it up like this vertically, guys, right? Because we have to put everything in the formula here vertically. And then all you do is extract the information from the problem and put it where it goes. So for example, here, right, the present value is 12,000. That's how much money Martha borrowed from her uncle. The interest rate, right, it's kind of easy to observe because it's a one that has the percent symbol. So it's going to be 3.5%. And remember, convert it into a decimal. So it's going to be 0.035. And the time will be in years, 5 years. So we plug into the formula. Right, there's my present value. And there's my interest rate times the time. You plug it into the calculator. And you're going to get 14,100. But if we use the future value formula, then we have to use another formula that goes with it, which is the interest rate is equal to the future value minus the present value. So this tells you how much extra money that Martha paid, which is the interest. That's the future value was 14,100. And the present value, the amount that Martha borrowed was 12,000. So if we subtract it, it's going to give us 2,100. So total Martha paid was 14,100, and interest paid was 2,100. Okay. Let's do another example. Example number 2. Example number 2. Here it states that Mariana will need to pay a tuition bill of $7,500 for her daughter in 10 months. What dollar amount can she deposit today at 1.25% simple interest to have enough to pay the tuition? Hey guys, so in this one here, we don't have an option. We have to use the one that says the future value formula. I mean, future value equals to present value, 1 plus interest rate times time. Why? Because Mariana will need to pay a tuition bill. You see, she needs to pay this much in 10 years. I mean, in 10 months. So then we're forced to use this formula here. So we're looking for what dollar amount can she deposit today. So we're looking for, what we're looking for? We're looking for the present value, right? How much money must she deposit today, which means right now at the present value. So then the 7,500 is going to be by my future value. My interest rate, right, is always, like I said, it's easy to observe because it's a one with a percent symbol. And remember, convert it to a decimal. So it's going to be 0.0125. And the time is 10 months, right? So here we have to be careful. Here's where students make the mistake that they put 10 for T, which is wrong because it's in months. So it's going to be 10 divided by 12. Okay. So then all we do is plug into the formula. Okay, now these two formulas are the same because to solve for the present value, we divide both sides by 1 plus RT, right, to both sides. So we have PV equals to future value divided by 1 plus RT. This is what the book uses. When I show my students, I don't like to use this formula because it's harder for students to use. To actually put into the calculator. Okay, but I'm going to do this example that way the book does it, and then I'm going to show you how I show my students. That way you have another option. So here's the present value, right? So the future value is 7,500. The interest rate is 0.0125, and the time is 10 divided by 12. So if you put the numerator stays how it is, but in the denominator, if you put it that on the calculator just how it is, it's going to give you 1.01041667. Hey students, if you happen to have a calculator at your hands right now at your disposal, please take it out, and that way you can see actually how we get these numbers here. Okay. If you have any questions during my presentation, you're always welcome to put it in the chat, or you can put it in the chat, and Miss Patricia will tell me what the question was. So then, guys, so if we divide 7,500 divided by 1.01041667, it's going to give us 7,422.68041. But remember, guys, when it comes to money, we round off to the hundredths place because we round off to the nearest penny, which is here where the 8 is. So we always look at the 0. If the third decimal place is 5 or more, we add 1 to the hundredths place. But if it's not, we leave it how it is. So the answer will be $7,422.68. If you round off too early, you're going to get the wrong answer, because most of the times in my math lab, they want you to round off to your nearest penny. So if you round off, like I said, too early, you're going to get the wrong answer because you have to simplify it or round off to your nearest penny, which is the hundredths place. Okay. Now let me show you the way I show my students. Another way without clearing the calculator. Okay, this is very good for a TI-83 or TI-84, which are permitted in the 1324 class. Okay, now again, there's a formula, so I'm going to plug everything in. So here's what I do. I tell my students to enter 1 plus 0.0125 times 10 divided by 12 in the calculator just the way it is. Okay, also with parentheses. You should get 1.01041667. Then you can enter, this is the inverse key, which means that you're going to multiply you're going to multiply both sides by the reciprocal of 1. That's what it means. You're going to multiply by the reciprocal. Okay. Then once you hit the inverse key on the TI-83 is located on the first column, the fourth row. Okay, that's where it's located. Okay, now once you hit that key, when you press on the inverse key, this is what you should see. Answer to a -1. Then you enter 7,500, and it gives you the answer. Right? You enter it, and it gives you the answer. So this prevents by using another formula, because at times students they're not given the formulas; they have to memorize them. So by using just this formula, the future value formula, right? You can derive to the present value by dividing both sides by 1 plus RT to both sides, right? But anyway, you can use this simple formula, guys. You don't have to remember another one or try to derive for the present value formula. Okay. Okay, now simple interest continues. Example 3. John received a $10,000 loan from his aunt to buy a car. His aunt charged him 2.5% interest. How long was the term of the loan if the interest accrued was $125? So here, guys, we don't have an option of what formula to use. We have to use the interest rate formula, which is the interest is equal to the present value times the interest rate times the time. How do I know that? Because it gives us the simple interest or the INT, the interest earned, and they give us also the present value. Right, so we're going to use this formula here. So here, let's see what they give us. John received 100,000. Well, I'm sorry about that. We're looking for the time, right? This is how long, it means time. But here they give us the present value, which is 10,000. What else do we see? The simple interest earned was 125. Right? It was 125, and the interest rate was 2.5%, which is equal to 0.025 because we converted to a decimal. So now let's plug everything in. Okay. So here we're going to multiply 10,000 times 0.025, gives us 250. Then we're going to divide both sides by 250, and it should give us 0.5. So t is equal to 0.5 or half a year. That's the answer for number 3. Okay. Now we're going to be doing this is something from 5.2, which is compound interest. How do we know which one's which? When they say simple interest, it means section 5.1, which is the simple interest formulas. Now in 5.2, the key word is compound interest. So that means we're going to do it using the formulas from 5.2. So this is a formula for 5.2. But this formula can also be the future value equal to present value 1 plus I to the nth power. If you notice here, guys, my R divided by M is the same thing as my I. You see it right here on the bottom. And my MT is equal to N. So I tell my students to use this formula instead, the future value equals to present value 1 plus I to the nth power, because it's easier to input in the calculator. But both formulas will work. So now, what does everything stand for? The future value means for the future or maturity value. The PV stands for principal or present value. The R stands for the interest rate per period. Convert to decimal, right? Convert to decimal from percent. The M stands for number or compounding periods per year. The T stands for number of years. The I stands for R divided by M, means interest rate per period. And the N stands for M times T, which is the total number of compound periods, or this is the total number of payments. It's just another word for the N, total number of payments. Okay, now on the right side, there's keywords for the compound. For the compound periods. Okay, compound keywords for the M. For example, if the problem states yearly or annually, my M is equal to 1. If it states bi-yearly or semi-annually, my M equals 2. If it states quarterly, my M is 4. If it states monthly, my M is 12. If it says weekly, my M is 52 because there's 52 weeks in a year. If it says daily, it depends on the book, right? But there's supposed to be 365 days on a year, right? But at times the book wants you to use 360. If it's not specified, then use 365. And if it says continuous, compounded continuous, then it's a different formula, which is future value equals to present value, e to the RT, to the power of RT. Okay. Compound interest can be used to invest a certain amount of money without depositing additional money. So, for example, if you have like a lump size of money in your house, right, or underneath your mattress, you can always invest it at a bank. You don't have to put no money in; just invest it for a certain amount of time, and you're going to earn interest. Okay, let me show you an example. Example 4. Say you deposit $1,000 in an account at your bank that pays 6% interest compounded quarterly. How much money will be on your account after 5 years? And how much interest did you earn? So again, let's get the formulas right. So let's put, I like to use this one instead, right? I put easier to input in the calculator. Okay, so anyway, I use all these. There's going to be 7 things, right? There's the future value, present value, the interest rate, the compounded amount, the time, the I, and the N, right? The I is equal to R divided by M. Well, first of all, here on the problem number 4, what are we looking for? It says you deposit $1,000 in an account, right? So we're looking for how much money will be in the account in 5 years. So we're looking for the future value. And here's the key. How much money will be in your account after 5 years? So this is in the future. So then let's begin to input extract all the information from the problem and put them where they belong. For example, the deposit means present value. the interest rate, right, that's the one with the percent symbol, is going to be 6%. But don't forget to convert it to a decimal, 0.06. The M, right, the M compounded quarterly is going to be 4. The T is going to be 5 years. And the I is R divided by M. Here's what I tell my students. If it gives you like a finite number, a number that has an end, well, actually use the I. But if the number continues if it's an infinite number, like point something 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 that never ends in your calculator, then leave it how it is. So for example, this one here, 0.06 divided by 4 will give you 0.015, so that's finite. So that way, that can be your I. And the N is M times T. I'm sorry about that. 4 times 5, right? M times T is, the M is 4, the T is 5. So it's going to be 20. So let's plug everything into the calculator, right? There's my present value. There's my I, 0.015, and there's my N is 20. So how do we get that, right? So if you can enter it just the way it is in the calculator, okay? So you should get something like $1,346.86, because remember, if the third decimal place is 5 or more, you add 1 to the second decimal place, right? Which is the pennies here. So after 5 years, it will be $1,346.86. So the second part, how much interest did you earn? Okay, so then how many payments? No. So here, right, it's going to be the future value, which how much money did you earn was 1,346, right? So it's going to be 1,346.86 minus the money that you invested. So you earn $346.86 in interest, which is not bad, right? Just for 5 years if you have the money to deposit. Okay, now comes the continuous compound interest. So you notice it's the same problem, guys, but now it's compounded continuous. But before I go on, let me go back to the previous slide. Hey guys, please let's write down how much interest was earned, right? So the interest earned was 346.86. So if it's compounded continuous, how much more interest will it be? Okay. So again, the same type of problem, but instead of compounded, it's going to be compounded continuous. So it's a different formula. So here, right, we're looking again for the future value. So this is my present value, 1,000. My interest rate is 6%, 0.06, and my T is 5. Plug it into the formula, enter it just the way it is. The E value, or the E in your TI-83, TI-84 calculator is going to be on the first column, 1, 2, 3, 4, 5, 6, on the 7th row. Okay? So here we have to be careful. It depends on your calculator. So to play it safe, you always put it in parentheses to play it safe. Because if you put 0.06 and then you put times 5, what the calculator does, it follows PEMDAS, which is order of operations. Or just to play it safe, just put it in parentheses. This way, you're entering it correct. Okay? To play it safe, put it in parentheses what goes here. So then this should be your answer, right? 1,349.858808. So it runs off to $1,349.86. So in reality, it's going to be like $3 more. Exactly $3 more. So the more that it's the higher the compound. For example, if M is continuous, you're going to get more interest. And for example, if it's compounded annually, you're going to get less interest. Okay, so that's the way the banks work. When you're trying to borrow money from the bank, they want you to pay more interest, right? But when you want to put money into the account so they can pay you interest, they'll give you it's compounded at a lower rate. Okay, and that's why I want to show this example. The higher that is compounded, the more money, the more interest you will get. Okay, or you will pay. It's either or. So after 5 years, there will be $1,349.86 on the account. So how much interest did you earn? So it's going to be the future value minus the present value. So it was $349.86. Okay. Now compound interest continues. Example 6. I want to be earning an annual salary. This is like a real scenario. Say that you're going to a job interview, right? And the job is yours, but you want to retire in 15 years, and the last year you want to be getting an annual salary of $100,000. So how much should you ask? To start off, your starting salary. So this is an example that you want to have $100,000 and when you retire in 15 years. So how much money should you ask for? For the starting salary if it's negotiable. And they're saying that there's an annual salary increase of 4% per year. So then, right, so we use the same formula, right, the simple interest formula. And again, this is easier to input in the calculator. But here, I want to be earning an annual salary of $100,000. So here, what are we looking for? We're looking for the present value, right? We're looking for how much money how much money you're going to be asking for, because the starting salary is negotiable. So we're looking for the present value. So the future value will be $100,000. The interest rate will be 4%, 0.04. Let's see, annual, right? So earning annual salary, so that means the M is equal to 1. The time will be 15 years. So the R divided by M will be 0.04 divided by 1, which will just be 0.04. And the N is M times T, so 1 times 15 will give you 15. Plug everything to later. Okay? And here, again, guys, I'm going to show you 2 ways, okay? I'm going to show you the way most of the students do this type of calculations, and then I'm going to show you how to use the inverse key. First, all right, so you're going to put how it is here in the calculator, parentheses 1 plus 0.04 plus parentheses to the 50th power is going to give you 1.80094356. Then you're going to divide both sides by 1.80943506, and it's going to give you 55,526.45027. Round down to your nearest penny will give us $55,526.45. Okay. Okay, now here's how I show my students by using the inverse key. Okay, so let's go straight from here, right? When we plug everything in. So here, I'm going to put it here in green on the side, guys, right? So we're going to input parentheses 1 plus 0.04 to the 50th power in the calculator. You should see 1.80094356. Then you're going to hit the inverse key, press inverse key. Once you press the inverse key, you should see answer to a -1 means this answer to a -1, answer to a -1 means they're going to multiply by the inverse. Then you're going to enter the 100,000. You're going to get 55,526.45027, which runs out to $55,526.45. The formula used by the book is this formula that I show you, similar to the one I showed you earlier. But like I said earlier, that most of the times you cannot use. You cannot have the formulas for the exam. You have to memorize them. So it's easier to just use this formula. And you want the present value, you can do it the way I'm showing you with the calculator here. Okay. Now comes this is 5.3. The future value of an ordinary annuity. So these are the 2 formulas, and again, the R divided by M is replaced by the I, and the M times T is replaced by the N. I like to use this formula on the right better. Okay. So on this one, why are these useful? These are useful because future value ordinary annuities can be used to accumulate funds for some time in the future. you must save regular deposits during that specific time. Here are some examples. Let's say you can afford to save $1,000 every month and you want to set up an annuity to make interest on the account. So in other words, $1,000 every month is left over from after you spend all after you pay all the bills and everything, you have $1,000 left over, and you just have them there. So you want to deposit into an annuity account so you can make interest. Okay, and again, you want to deposit $1,000 at the end of every month for 20 years. How much money will you have at the end of those 20 years? Another example. Let's say you are planning on sending your just born child to college when he or she turns 18. Because right now, guys, when you come into school, it means that you're going to be making good money, right? Because that's the purpose of attending school. You want to graduate, and then hopefully you'll be set up with your degree, right? And then hopefully you get a good job, good paying job. And more than likely, when your kids are growing up, they won't get financial aid no more, right? Like you did, you got financial aid because you'll be making too much money and they won't qualify. So this is a good example how to set up an account, an annuity account. So when your child turns 18, he or she will be able to attend college. Okay? And I'm going to do these two examples right now. So again, this is example number 7. Okay? So you can afford to save $1,000 every month and you want to set up an annuity to make interest on the account. An investment company offers, let's see here, offers 3% interest for 20 years if you deposit $1,000 at the end of every month. How much money will you have in 20 years and how much interest will you earn? Okay. So here's my formula, right? And again, I like to use the I instead of the R divided by M. So let's put everything down, right? So what are we looking for? Let's see how much money will you have in 20 years, right? So here, we're looking for the future value. So the payments that you'll be paying every month is going to be $1,000. And again, the interest rate is very easy to observe because it's a 1 with a percent symbol. So it's 3%. But you have to convert it to a decimal, 0.03. Let's see how much maybe you want to set up an annuity that makes interest. Compound, let's see how much you compounded. You're going to put every month, right? So every month means 12. Right here it is, every month. And the time is 20 years. So the I is what? R divided by M, 0.03 divided by 12. You see, it gives you a nice number. And the N is M times T. 12 times 20 is 240. So let's plug everything in, right? There's my payment, 1,000. There's my I is 0.025 to the 240th power minus 1 divided by 0.025. So here's how we're going to do it, right? So you always do the top first. So 1 plus 0.025 to the 240th power will give minus 1 will give you 0.8207549953 divided by 0.025 is going to give you, right? These two are going to give you 1,000 times 328.30199981. You multiply those, and it's going to give you what? 328,301.9981, which runs out to let's see here, to 2, right? Because we go here, right, to the 8. If that's more than 5, we add 1 here. That goes to 0. We add 1 here. It goes to, that one goes to 2. So this is how much money you have in the future in 20 years. Okay? Now, let's see how much money came from your pocket and how much interest did you earn. So here, guys, right? How to use calculator. Before I continue, how to use calculator without clearing or stopping on one steady flow. So here's going to be in green again. You input 1 plus 0.025, 240 minus 1 in the calculator. You should see 0.8207549953 on the screen. You're going to press right divided by right because divided by. You should see answer divided on the screen. Then you're going to enter 0.025, enter. You should see 328.3019981 on the screen. Then you're going to press the times key, right? Because you're going to multiply by 1,000. You should see that on the screen. You're going to multiply, enter 1,000 because you're going to multiply it by 1,000. It's going to give you, right, the value that we got here. You notice? So 301.9981, and it runs off to $302. So how much money did you invest? So here, guys, we're going to multiply the payments, 240 payments times 1,000. So you made 240 payments of $1,000. So you're going to multiply those out. So in reality, you only put in 240,000, right? Because there was 240 payments at $1,000 per month, which comes out to 240,000. So this is how much money you had, right? I mean, you had after 20 years. So how much money came in interest? So $88,302, guys, which is not bad at all. If you could do that, you see that's how I show my students how to set up money. I mean, for like the example for the kids or for themselves, to see how much money they can have when they retire. I mean, stuff like that. So anyway, this is a good example, guys. But $88,302 is a lot of money. Okay, now future value. Okay, let's continue. Let's continue now. Now this is the example that I showed you about that you want to send your just born child to college. Okay, you are planning on sending your just born child to college when she turns 18. Say it's a female. You want to have 250,000 in an account for tuition in 18 years. How much money must you deposit at the end of each quarter in an account paying 5% compounded quarterly? So in other words, that's how much money you want to have in 18 years for your child to go to college. So let's see how much money you must invest right now or input right now. Okay, so again, we're looking for the payments, right? So the future value, you want 250,000 in 18 years. So the interest rate is going to be 5%, right? So it's going to be 0.05. Compounded. See here. Let's see what it says. Compounded quarterly. So this is 4. The time is 18. The I is R divided by M, which is 0.05 divided by 4, and it gives us something real nice, right? A finite number, 0.0125. The N is M times T, which is 4 times 18, which gives us 72. You see, now we plug everything into the calculator. Okay, but now, guys, I'm not going to do it the way most students do it. I'm going to show you how to do it in the calculator without like in a steady flow. So this is what you're going to do. You're going to input here the numerator, which is parentheses 1 plus 0.0125 plus parentheses to the power of 72 minus 1 in the calculator, just the way it is there in green. You should see 1.459202268 on the screen, right? Then I'm going to hit the division key, right? Present division, because that means division. Once you do that, you should see the answer division on the screen, that in black you see on your screen. Then you're going to enter 0.0125, right? Then when you enter that, it means that it's going to be the numerator divided by the denominator. It's going to give you 115.6736215 on the screen. Then here you're going to press on the inverse key, right? And I repeat, the inverse key on the TID3, TID4 calculator is located on the first column, 4th row. Once you press on the inverse key, you should see answer to a -1 on the screen. Then you're going to enter 250,000. Then you should see 2161.25334, which runs off to a nearest penny to 2,161.25. You see, guys, this is very simple to do in the calculator. Okay, so then those are your payments, right? That's how much you have to deposit at the end of every quarter, which is every 3 months. That's how much you have to deposit. Okay, now this is extra information, right? So let's see how much in reality came out of your pocket. How much money did you put into the account? So you're going to multiply the number of payments times the payment. So 72 times 2,161.25, which will give you 155,610. So that's how much you actually paid out of your pocket. So now how much interest or how much interest did you earn or how much free money did you get? So we're going to subtract, right, the total, the 250,000 minus 155,610, which you actually put into the account. So you're going to earn $94,390. Okay, so this is actually like a real life problem that at times I ask my students what type of problems do they want to solve here. So most of the time students give me problems like this, like about cars and stuff and houses, and that leads to the next section. Okay, but now guys, you have an idea, right? How math works in business, right? In money. So now you can make some good investments. Now comes, this is from 6.4 or 5.4, the present value of an ordinary annuity. So this is the formula, and again, the formula is a little bit different, but I replaces the R divided by M, right? As you see here, the I is here, and here in the denominator, so it replaces the R divided by M, and the M replaces the M times T. Okay, now what type of problems can we use this? Most common use of present value ordinary annuities are for purchasing an expensive item such as a vehicle or a house at the present time and making equal payments including interest for a certain amount of time and years. Here are some examples. You want to purchase a car. What are your monthly payments and how much will you end up paying? You want to you want to get an idea on the process of purchasing a house. So what's the process of purchasing a house? These are the key factors of purchasing an expensive item in payments, which is a house or a car. First of all, you must have a job, right? Because with no job, the bank is not going to lend you no money. You also must have very good credit. The better the credit, the less of the interest you pay. Okay? Again, the higher your credit score, the lower interest rate you will get. And you have to get pre-qualified for the maximum amount of a loan. Because when you're buying an expensive item like especially a house, you have to get pre-qualified with how much money you earn every year. Because if you don't earn enough money to buy like a really expensive house, right? The agent is wasting his time if he doesn't pre-qualify you first. Because if you qualify, say for a house for 150,000, you don't want to see nothing more than that. Because once you see something that's more expensive that when you can afford, then all the houses that are worth less than 150,000, they're not going to be to your liking, right? Because you got used to seeing something more expensive. So it's always good to get pre-qualified, and also do not look at houses more expensive than when you can afford. Okay, so those are the key factors here. And again, when I ask my students what do they want to purchase when they graduate, most of them say these two things here. They want to get a real expensive car because they say that they earned it, and they want to get a nice house. Okay, so that's why I came up with these two examples. Okay, example number 9. You buy a new car that costs $26,750. What are your monthly payments if the interest rate is 4.2% and the loan is for 5 years? How much interest did you pay? Okay, so let's find out. So the formula, so let's put everything that we need. So we're looking for the payments, right? What are the monthly payments? So the loan or the bank loan you that's money right now at this present value to purchase a car. So that's the present value, which will be $26,750. The interest rate is 4.2%, which is 0.042. Right? I guess when it comes to cars and houses, most of the time it's monthly payments. So the M is going to be 12. The time is 5 years. So the I is R divided by M will be the R divided by M 0.042 divided by 12 equals something real nice, something finite, 0.0035. So it's going to be a total of 60 payments, right? Because 12 times 5 is 60. So let's plug everything in. And again, I'm going to be using the way I'm showing you I'm going to do the inverse key. Okay? Because every time that they give you the future value, right, or the present value here that you're looking for the payment, or the present value that's here, you always use the inverse key. Well, it's easier to use the inverse key. So you're going to enter the numerator in your calculator just the way it is. So you're going to copy it just the way it is in the calculator and put it into the calculator. Once you import that, you should see 0.1891185,031. Then you're going to hit the division key, right? Because division, you're going to divide by 0.0035. But when you put the division into the division key, you should see answer, right? Like that. Like this is what you should see in the screen, answer, and then with the division symbol there. Then you're going to enter 0.0035. Once you enter that, it's going to give you the answer for this whole thing. For the numerator with the denominator. You should see 54.03385,802 on the screen. Hey guys, that's but let me show you why I like to use this key here, because if you're doing other steps, to me it's too much work writing all that down every time. Because if you cut it short, for example, if you didn't put the 0.1891185,031 what's on the screen there, if you say you only put 0.189, then it's gonna be a little bit off. And my math lab will kind of wrong, because my math lab runs out to a nearest penny most of the time. That's why I don't like to write everything down, because to me that's too long to be writing. Okay, but that's my opinion. So then, right, so then you're gonna press on the inverse key. All right, and this is what you should see on your screen. Then you're gonna enter that 26,750. You're gonna enter it, and it's gonna give you 495.0599675, which runs off to $495.06. So those are your monthly payments. Okay. So then let's see how much extra money you paid, right? Because you make 60 payments. So let's multiply the 60. How much money did you end up paying? So let's multiply the 60 times the monthly payments, which is $29,703.60. So how much extra did you pay in those 5 years? Right, so that's how much you paid for the car, which was close to $3,000 more. So you end up paying $2,153.60 more. Okay. Now, since it's almost time, let me do the last example. So you paid that's how much you paid in interest. Now this is my last example here, guys. Okay. Now this is about a house. Hey guys, I like to have fun with this example here, because after I show some examples to my students, I get some feedback from the students. For example, I might say, hey guys, I see who wants to volunteer that once they graduate, how much money they're going to be earning and what type of house they want. So this was an actual example. The student said she wanted to buy a $325,000 house once she graduated, right? Because she said she was going for a mechanical engineer, and she was going to be making good money. So let's see if she was able to afford it. But first, right, I told her that you have to get pre-qualified, but we'll just see how much the payments are going to be. And most houses are at a fixed rate at 30 years, or most of the time it's 30, 20, or 15, but most of the time it's 30 or 15. Okay, 15 years. There's my formula. Now let's input all the information, right? So you want to purchase a house, $325,000. So we're looking for the monthly payments. So this is the amount you're going to get from the bank, right? Once you qualify. So the interest rate is 3.9%, which is 0.039. And again, their monthly payment, so the M is going to be 12. The time is 30. The I is R divided by M, which is 0.039 divided by 12. Again, it's something nice, 0.00325. So if it's 30 years, right, it's always going to be 360, because 12 months in a year times 30 will give you 360. So let's plug everything in. And again, I'm going to show you how I show my students by putting everything in the calculator with a steady flow. So you're going to input the numerator in the calculator just the way it is. And you're going to get, you should see something like 0.6890436,901 on the screen. Then you're going to hit the division key again. Then this is what you should see. Then you're going to enter 0.00325. You should see 212.01344431 on the screen. Then you're going to press on the inverse key. Once you press the inverse key, this is what you should see answer to a -1, which means you're going to multiply by the inverse of what's over here, which was 212.0134431. You can enter the 325,000 that was on the left side. So this is what comes out, 1,532.921664, which runs off to 1,532.92. So those are going to be your monthly payments. But you also have to get into consideration, right? Also the taxes. How much taxes are you going to pay if you live in a nice area? And also the insurance of the house. So, but this is just the monthly payments without the insurance and also without the taxes. So now, let's see how much money you end up paying in reality. How much money did you end up paying? So we're going to multiply the number of payments, which was 360, at $1,532.92 per month. So it's going to give us, so you end up paying $551,851.20. How much interest did you pay? You paid a lot for the house, right? So you paid like almost 200 and something thousand more. This is how much money you end up paying, guys, extra. Isn't that amazing, guys, in 30 years? But here's a way not to pay that much interest. If you have extra money every month, just pay just put it into the principal. Send the money to the bank and tell them that this goes to the principal, that you want it to go to their principal. Because eventually, guys, when you purchase a house, the first payment, like a whole chunk of the payment goes to the interest. The bank wants to get its money first. And I believe at the midpoint, at the 15th year, if it's a 30-year loan, I believe it goes like half and half. Like half goes to the interest and half goes to the principal. Then on the 15th year, the first month after that, a little bit more goes towards your principal. So you can avoid paying all that money extra by giving large amounts of money every month that goes straight to the principal. Okay, and now use that technique to pay off the house in 10 years. The house that we have here. Okay, I don't want to say exactly how much, but I ended up paying like the house that we bought in 10 years and about 2 months, because I applied the math that I learned when I was a student taking this course back in 2005, 2006. Okay, guys, so you guys can use some of the information in this presentation to actually know how to purchase a vehicle and how to be smart about investing some of your money, guys. Okay, so thank you guys for your for your time. And if you want this PowerPoint, guys, with animation and everything, send me a text at aisasi@abcc.edu, and I'll be more than happy to send you this PowerPoint. But you can also watch the PowerPoint. This way you have the explanation. Okay, guys, let me stop sharing my screen. So, any questions? Well, thank you, guys. Thank you very much.
Alrighty. Thank you so much to Mr. Sassi for presenting today, as well as giving us those financial tips. I want to thank the audience for coming and being a wonderful audience. We hope you have a wonderful fall semester, and there's also online tutoring available in case you guys need any sort of assistance. I would like to invite you guys to next week's Happy Math Hour session, which will be a review session for exam number 2 for both 1314 and the 1324. So we hope to see you guys next week.